presents Dr.V.THANGRAJ with a shawl and a fruit basket.
Sir, can you get down?
I also request our principal to honor our chief guest, Dr.S.Udayabaskaran.
Sir, sir. Sir,
Mohan sir to share a few words with us.
Assembled here for the inaugural function of the Fdp being conducted by Mathematics Department of Art College and approved by Rangarajan University. See, when I was told that I should address the gathering here, I could recollect the great saying of Napoleon Bonaparte, who was the benevolent despot of France. He said once that ability is little account without opportunity. That means, the meaning of which is that you may have talents, you may have skill, you may have the knowledge, but unless an opportunity is given to you, nothing can come to limelight. So that opportunity should be given, or it should be given. That's what I say. So only when it is given, you see that you will be known to the world that you are having such a talent. And coming to this, how this is connected, I want to tell you that. Our employment, I should say that, I use the word our employment. Our employment in this college is being given by our beloved chairman, and who is a philanthropist, who is an educationist, and more a patriot. Has he not given this opportunity, I don't think that we will have the opportunity to conduct this and make known to the people that we have got this talent and we can also conduct. And the Anna University has recognized that these people can also conduct. So my sincere thanks goes to our beloved chairman who has given us the opportunity. And I am here very much proud to say that I have grown with the growth of this institution, in this sense that our chairman, who has proved to the world that he is an educationist, and he has established so many colleges, and that he has made known to the world that our Dept University is one of the best. And as you know very well that it is being put everywhere, and it is also known to everyone that it has got its own recognition. And so my thanks to our principal, this beloved chairman who has given this opportunity. And I must say that before welcoming the people, that the cause must be thanked. Then only I can welcome the effect, in the sense that the cause of coming here is our chairman, and the effect is that we have got an opportunity to teach. So, or to show that we have got this much of stuff. So I thank our beloved chairman having given this opportunity. Next, I welcome our optimistic, most inspiring and encouraging principal, and I have got a lot of experience with him that whenever I talk to him, he is most encouraging, and he can understand the pulse of people, and he has encouraged in every way, and he has actually getting this from an university is mostly the effort of our principal and his team, and I wholeheartedly thank our principal for having got this and given an opportunity to the mathematics department to show that we can also do something here. Here, this particular thing is for FDP. Here, this FDP is being conducted for the third paper, that is the transforms and partial differential equations. And it forms the third paper for the engineering students, but now it is not for all the branches, only for some of the branches have got this. but still we want to just make them well equipped. Already the people who are coming here may be well equipped because they are conversant, and many have put more number of years in that, so they may be conversant. Still, they may be able to know because of the experience. Teachers, we have got professors here, and they can give something more of which they may not know. So I am sure that one who has come here as a participant will definitely gain as much as possible, and he can go. And here I really feel we have got amidst us two stalwarts of mathematics, and there is nothing to say about our Dr.Udayabaskaran and our Professor T.Thangraj. They are known to the fraternity of mathematicians here in China and also outside. Their contribution is something enormous. Nobody can imagine. That is how and I feel that really I am honored to welcome them and honored to just talk about them. It is a great privilege, I should say that. And they are here, and they are here to encourage us, and they are here to give this thing, what you call lectures on that. And I am sure that everyone will benefit by the experience of our great personalities here sitting here. And I welcome everyone here for this session, and I want those participants to regularly attend and interact with the professors who come here to impart the knowledge and gain as much as possible, and leave to them also what that you have got with you. Thank you very much.
I welcome Principal Sir to share a few words on Faculty Development Training Program.
Learned academicians, the great mathematicians who are here, Dr.V. Thangraj and Dr.S.Udayabaskaran sir, and Dr. Mogan Professor, and Dr. Bhagaraja, and my dear deans, heads, faculty members. Really happy to have this FDP exclusively on mathematics, TPD. I think this is the first time we are conducting NITEC. Is it right, sir? On mathematics. Some 20 days before, somewhere, I think, suddenly there was a communication that the last date is by next day or next day to apply for this. And which are the departments to apply for this FDP, so that at least one FDP that we will get it from Anna University. Otherwise, by not choosing some important areas, even Anna University will not approve. Anna University will not approve. And we had a thought that to see that some departments which are unique, so that they all, and then immediately we thought of going for biotech, chemical, and then for mathematics in SLH. So immediately then communicated to the departments, and then they made it the proposals ready, and then we communicated to Anna University. So after 10 days, we received a letter from Anna University that our mathematics has been approved to conduct here, transforms partial differential equations, TPD. So really, to have this FDP at this juncture, it is really good. Mathematics plays a major role in the country or even in the world. People need to understand, and even our younger generation, they are fear of this mathematics, going away from mathematics, But what is important, we are forgetting it. But what is not important, we are concentrating more. But without mathematics, we cannot survive in this world. So, even you are a computer science engineer or electronics engineer, or a chemical engineer or any engineer, production engineer or mechanical engineer or any engineer, you need to work with a lot of calculations with the mathematics. We have to apply formulas and many other things. So the most wanted and to be learned in this world by the people, this mathematics. So that is why even I insist here in the institution, mathematics in such a way that the mathematics department to take up this importance to the younger generation, the students of this engineering community, to tell them that the importance to learn, it is not that only for simply getting pass mark. To get a pass mark, they have to involve more and more. Really, the students who are doing good in mathematics, definitely, at the end of the program, this engineering program, they will get into what actually they require. There is no doubt in that. The analytical ability, the capability of the student definitely that turns automatically and tunes the mind, and they can comfortably learn where actually they want it to be. So that helps in many ways. Even we are talking about research. I am not that much grown-up person to talk about research in front of the learned professors actually. Even for research, when you take up something, even into that you add some essence, the layer, the mathematics, the modeling. When you come up with that, then you will come to know what is the weightage of the research, the kind of article that you want to publish. So without mathematics, people, we land up in writing many things, paragraphs, and saying that 8 pages, 10 pages, 12 pages, an article, and we publish it, by mixing something and the theory, the version, and we bring out in the name of an article. But really, there should be some mathematics. Really, there should be some mathematics in your research paper. That gives you an idea, the modeling, and that you can integrate with your other technical, the kind of engineering what you learn. When you integrate it, and then automatically that gives you that the outcome of the article, Even I did my research actually for some time, and then I thought of that after some years. Normally a researcher will come to know to do some real research, where to go and where to get some the great learned professors in mathematics, such a way that I landed. I am very fortunate to say that Dr.S.Udayabaskaran sir and even Dr.V.THANGRAJ sir, I took help from both of them. I am saying to you now, really it is fantastic, the kind of mathematics really. But for some extent even I cannot go in deep such a mathematics, wonderful equations, integral equations with Dr. Udayabaskaran sir. The flow that the way that he explains, really, it is fantastic actually. So therefore, the thing is that the followers of the great professors, that they have to learn. Even in fact, even if I think I cannot go because the situations, the kind of activities what we have here, the job designations and other things that restricts, not to go. But really, the mathematics, the faculty members, really they can travel behind such professors to learn many more things and to see that to evolve in research or to bring out even some textbooks or some good articles, many things. So therefore we have here the great personalities for this FDP. Faculty members can train well in the area of with respect to the semesters based on the Anna University curriculum, the defined curriculum, the expertise that you can build up you can develop further where you are lagging, where is our weakness, that we can identify, so that fruitfully how can we deliver after going through such workshops, FDP to the students. So you bring the minds of the students that my mathematics faculty will help. I need not worry about the mathematics. Definitely I'll get pass, or even not to see that to get pass mark, I'll get good marks in mathematics. I want to learn mathematics. Such a confidence that you have to build up, with the students. So they have to, run by seeing the mathematics or any other subject. That kind of interest that we have to create, with students. That is what the learning environment. That learning environment that the faculty members that we have to bring in the campus. Then you can see that really students who are learning and doing many things, better, so that what is expected from them at the end of the day, end of the program, really something which is measurable. So therefore, this 7 days workshop really which will give fruitful outcome with our professors, even externally invited members from Anna University who also come for the FDP based on the schedule given here. I think take up very seriously, and members saying and engaging in some other activities, it is not nice also. So when such FDPs are conducting in the campus, faculty members, you have to involve and you have to take participation for full length for 7 days without missing any hour. Then only we will come to know the importance. Then only we know what is the learning in 7 days. Right? Then as a faculty, where we are actually, what is our strength and the kind of interaction with the members of the FDP as a resource person, what is their guidance that you are getting. So all these things very important for a faculty member. So faculty is adding something plus, so that helps plus for students. So that is how even we are expecting from the faculty members something different. We want from the mathematics, even from the members of the maths department, something slowly we can progress, and therefore we can also attract students' minds. There is no doubt in that. When you take some effort, definitely that will happen in the campus. There is no doubt in that. I think the 7 days will take you for some greater height, to see that some learning. So thanks for giving me this opportunity. Have a great FDP workshop for 7 days. Thank you.
Valuable words. It's a pride having Dr. V. Thangraj, Professor of Mathematics at Dept University. He was the Director and Head of Ramanujan Institute of Advanced Mathematics at University of Madras. He was also the Director of Institute of Distance Education at Madras University. He has undergone several computer science courses at IIT, EDISET training at UGC Consortium for Educational Communication at New Delhi. He was the coordinator of Pan-African Network Project, Ministry of External Affairs, Government of India at University of Madras. He has 33 years of experience in the field of teaching and 40 years of experience in the field of research and development. 46 MPhil students have worked under our Professor Dr. V. Thangraj. He has involved in 8 national publications and 47 international journals. Now I request our Honorable Chief Guest, Professor Dr. V. Thangraj, to share a few words with us.
Good morning to one and all.
Good morning, sir.
This so-called FDP for which we have assembled here, respected principal, my friend, philosopher, Dr.Udayabaskaran, and Dr. Mohan, Dr. Bharadiraja, other distinguished faculty members, of course all are faculty members. I think it is a very pride to be a teacher. Now you are a teacher for engineers, and therefore you are mathematical engineers. You know the very, very world famous Ecolo Polytechnic. You should not forget whenever you see partial differential equation. When you see the history of partial differential equation, how the symbol partial delta evolved, that itself is a story. Whether it started with Newton or started with Dirichlet, there are so many controversial things. Even you can see that the Principia of Mathematica written by Newton, and he developed a calculus in the name of fluxions. Only Dirichlet at the same time developed the concept of derivatives, and there is a lot of controversy between Newton and Dirichlet. In fact, there is 27 pages of report whether who has studied first, because he is an Englishman, he is a German man. So at last Newton won, because he was the president of the London Mathematical Society. This report also published in the Proceedings of the London Mathematical Society. The controversy between Newton and Dirichlet. Not Dirichlet. Another gentleman started with D because of my age problem. Leibniz. Actually, he started with the symbol delta like this. That was first used, but it was rectified by Magnus in Ecolo Polytechnic. The Ecolo Polytechnic was instituted along with another engineer. They developed a school for engineering mathematics. From that day onwards, they have used delta like this. Earlier it was used like delta, but now that dou symbol we are using now, it was approved by the Ecolo Polytechnic mathematicians and engineers. Remember, at those days, engineers and mathematicians, they used to work together. And you know that name and fame of this is the Fourier series problem. This is what we are going to see in another 1 week. When I talk to you, my sound waves are going in a particular direction, but through mic it magnifies. So it is going peak and then coming like this. How are you going to do that? And there you have so many transistors there in that your box. That's all nothing but Fourier transform and Fourier series. And then Fourier transform, it is going to regulate everything, and then you are going to hear in a very nice way. I don't know whether it is knowing or unknowingly, the syllabus for this particular course, transforms in the partial differential equation, it is so very nicely framed. Because first I want to study the waves, right? So the waves means it will have a very peculiar phenomenon. It will go and then it will cross the x-axis, and then it will go, and then it is called like a sine wave or cos wave. It's called sinusoidal waves. Sinusoidal waves. And these sinusoidal waves, they have that period, mean repetitive nature. Okay. When you have the repetitive nature, and then here you have two types, whether it is a continuous type or discrete type wavelength. So now you are studying, if you have a period, then you have to use this or you have to study this via Fourier series. Suppose some waves, after transmitting through mic, it is going like, it is the original sinusoidal wave is disturbed and you are getting peak and then higher and then lower, for which you have to use transform, Fourier transform. So when you have to use Fourier series and when you have to use Fourier series put together in the same unit. So the Fourier series and the Fourier transform, which is going to analyze the system, whether it is a mathematical system or any other system. And then I think Laplace transform is also there. No, but Z transform is there. But they are all cousins. It should have been in the transform itself. Because this is designing purpose, you need the Laplace transform if the data is continuous. So you need Laplace transform. And whereas discrete, for designing purpose, you need Z transform. Now you have that four ideas. When you have to use Fourier series, when you have to use Fourier transform, when you have to use Laplace transform, and when you have to use Z transform. See, all are engineering oriented problems. Okay? So it is only first wavelength and then whether the data is available in a continuous form or in the discrete form, what type of transform you have to use. Other mathematical details are coming for 7 days, you are going to be roasted. Right? And then I take the three objects. I will take a wire, string, and then fix it in the end, left to right. Okay? That is a very thin string and I will hold it. I am not putting it on the horizontally, but I want to pull it vertically and I want to study the nature of the wave it is going to create. So one problem. That is about the string. Now you make that thick, it will become a rod. Okay? So when the rod comes and it is insulated, and then one part you want to put that heat, and then how that heat transforms from one end to another end. So that is another problem. And then third problem is the same rod, you make it as a plate, whether it is rectangular or square. Okay? Take the plate like a packet. When it is coming up, right? Like that, in the plate, now you want to give one heat one side. I mean, this problem may be applicable to conduction of electricity also, magnetism also. Okay, I am telling first temperature. Temperature coming from one side, how it is diffused to the entire plate. So started with the string, when it becomes thick it will become rod, and then this rod when you make it a plate. So these are all the three problems. That is what you are going to see as wave equation, heat equation and Laplace equation. That is what you are studying. So the entire course, it is only this. You are going to study about the string, going to study about the rod and going to study about the plate. Okay. So the entire syllabus it is framed like this. And then when the data is continuous and discrete, what type of technique you have to use I told. Okay. And then when you have equations, or usually it is started with people started with studying problems converting into differential equation. They don't know whether it is a partial differential equation even in the Newton's period. Newton and Leibniz. Right? Both have developed simultaneously. But they don't know whether they are developing partial differential equation. Without knowing that, they have developed in that theory. And there are a lot of, as I told you, a lot of controversies whether it really talks about total derivative or partial derivative. That is a problem. Remains still in the book, the Principia Mathematics. Okay. People have different ideas. But only after the beginning of the 19th century, we have a very good account about partial differential. Now its application is enormous. Direct applications to electrical engineers and electronics engineers. Now it has found applications in quantum mechanics, statistical physics, and robotics. I remember the silver book on partial differential equation used in robotics. How the partial differential equation, it is going to control the movements of robotics. It contains only partial differential. So in computer science also it is occupying a very good place in partial differential equation. So when we talk about the use of partial differential equation, it is just enormous. And recently it has found applications in finance, but with a different name. But the different name is stochastic partial differential equation. The three problems which I was telling you, they have converted into parabolic type, elliptic type or hyperbolic type. One of these types you are going to see it. And what the different methods of solving this. I know when I come to technical talk, I will give what are the different methods in each type. String problem, how many types? Rod problem, how many types? And then plate, how many types? These are problems that so far appeared in Anna University question paper. You can divide into only these parts, these techniques. So in these 7 days, when you master these techniques, the workshop will be successful. I am not going to give you any single problem. I am going to tell you only what you want to see. Then you will understand how to solve it. Right? Mathematics cannot be studied, cannot be read, but you have to do it. Do mathematics and make the students to do the mathematics. Right? I mean, by just nowadays, students are taking notes also through camera. I think that is a very bad way. In fact, it is useful for some purpose, but it is also dangerous for educational purpose. But how effectively you have to use that smartphones is entirely depends upon the person. But we should not use it for that purpose, because unless you work it out, you cannot successful in mathematics. Even if you do it repeatedly, then only you will understand what is really going on. But you should ask question. Next step means how it comes next step. What is the logic you are using it? Your entire proof or entire reduction, entire solution contains a set of logical rules. Only the logical rules, when you trained it, then you will become very good solution you will get it. One partial differential equation may have many solutions. And that also I will show you how it has many solutions. And then how to make it a unique solution. Because you cannot have two spiders in a jar or two lines in a den. Right? That should be one solution. So how to make it one solution? No doubt every cloud has a silver lining. But how to identify it? How the solution you have to find it? That is a problem in partial differential equation. You see, when the rate of increase or decrease, I don't know whether you are studying in the differential equation, especially when you want to find out the particular integral, First you will take the exponentials. Next you will take the trigonometry. And then we will take the algebraic. This is the way it is the order. Exponential is fast. Next list means trigonometry. The next list is algebraic. The partial differential equation also has three types. Exponential type solution, trigonometric type solution and algebraic type solution. So, which you have to choose? That depends upon your boundary condition or initial condition. Both together called boundary value conditions. Okay. So that is going to give you the nature of the problem which is given in the problem. That is going to give you whether it is exponential, trigonometry or algebraic. So that is where your ingenuity lies. These are all the tricks that you should know and you have to convey this to the students. Because engineering students. So these engineering students, these are all the simple, basic, rather primitive models of the string or rod or plate. But it will have different types of situation when it comes to practical problem. And they should know how to apply these techniques in their practical problems. That is why we are teaching, especially in this course, namely transform and partial differential equation contains periodic and non-periodic, continuous and discrete. And then solutions are exponential, trigonometric or algebraic. And what type of boundary condition, initial conditions. Whether it is given. In most of the textbooks, sometimes the questions without boundary conditions also it has appeared. Because I have seen, as a controller of examinations of Weltec, I have seen the question paper without giving initial condition and boundary conditions, they have given the problem. That means they can produce anything, any result. Therefore, the concession will get, the students will get the concession. Okay? Sometimes it's a very strange questions also. Because when you are sending for a question paper setter, he or she, they have a lot of confidence on their children. They will simply mark and then ask the children to type it up. They will simply type it up from the book, forgetting that in bracket they will give that which university and which year. And they will also type it the year and university. Maybe Venkateswara University, SV University 2010 means the question paper contains that. Because the question paper was not typed by the examiner or the question paper setter. Only his ward or his students. This is what it happens. There is many question paper you have to correct it. Suppose if the controller has not well versed with the question paper and he has not seen the question paper, means finished. It will go as it is. That scrutiny part, we must be very careful. When this I experienced here. So in this coming 1 week, you are going to see the different types of partial differential equations and how to solve them using initial and boundary conditions. With these few more remarks, I wish and pray to have a good knowledge and a good exposure of transforms and partial differential equations. People might have thought about why they have put two things together, whether connected or unconnected. Now you can understand why they have put Anna University people in this particular paper, transforms and partial differential equations. Okay? So that is where you need teachers. How to impart knowledge to the students. That they have done it. Okay, thank you very much for your patience. I will meet again after inauguration. Thank you.
Thank you, mathematics. He is a specialized professor of application of stochastic process. 2 PhD students are working under a Professor Dr.S.Udayabaskaran. He has 45 years of experience in the field of teaching. He has involved in the publication of 35 journals. He is a reviewer in mathematical reviews of American Mathematical Society, Communication in Statistics, Annals of Operation Research. He published 5 books including Engineering Mathematics 1 and 2. We request Dr.S.Udayabaskaran to share a few words with us.
Good morning to one and all. I am very happy that I am here in Veltech High Tech. First of all, as Professor Mohan has mentioned, I must be thankful to, first of all, to the chairman for the great opportunity he has given to me to work in this organization for more than 11 years. In fact, you can see in the Anna University website, I am still in the website of Veltech High Tech as a research professor. I was given recognition by the Anna University for guiding scholars in mathematics through Veltech High Tech. But suddenly I got the opportunity from the Veltech University, I should join as a professor. So the opportunity is still connected with the Veltech High Tech. It goes. Even though I am assigned to Veltech University, I am also a part of Veltech High Tech. Professor Thangraj has already mentioned I am a philosopher. So what philosophers will speak, it's very difficult to understand, correct? But I am not a philosopher. I don't want to be called as a philosopher. I still feel that I am a student. See, a saying is there. If one is willing to learn, he will definitely be a good teacher. If you shirk your interest in learning, you will not become a good teacher. I am telling you from my 47 years of experience. I joined a teaching profession in the year 1970. July 7th, my first day in a classroom. On the first day itself, my professor sent me to the third year B at Coimbatore Institute of Technology. So I went to that class without any fear. In fact, the HOD, Dr. he appreciated me. Puny fellow, you went to third year engineering students and you stood for 1 hour without any fear. Why should I have fear if I have something to teach, something to deliver to the students? There is no fear at all. Anyway, it goes that from 1970 onwards I am in this profession. Thanks to our chairman, as soon as I retired on the 31st of July 2007, 31st of July 2007, I was immediately called by about 9 p.m. in the night, 2007, 31st of May. I was very happy along with my wife to pack up all the things to go to my place. But at 8 p.m. in the night, I had a call from Veltech. Sir, you are coming here. You are joining us, our family. I said, sir, I have not decided. No, you come. That's all, the order. I just took a taxi and reached overnight to my place in Chennai. And morning I was here by 8 o'clock before chairman was already there. So by 8 o'clock I joined with him and he asked me to join immediately. Sir, I have not decided. No, you are joining. That's all. The order. Seeing at the love that the chairman has shown to me, I immediately gave my consent without asking my wife. In the evening, when I went back, my wife asked me, at what about distance? It is about 47 kilometers. Every day you are going to travel 100 kilometers. It's really a plain task. Don't join. No, I have given promise. I have to keep my promise. From that day onwards I am here. I think my wife is also happy because I am away from the house, See, retired people will have a lot of trouble in the house. They become unwanted. But I am wanted by chairman. Our chairman, I am wanted, I am here. So see this workshop, this is the second workshop in Veltech on mathematics. First workshop was conducted in 2002, sponsored by Anna University when I was here in the Well-Tech High-Tech as a research professor, in the list only, but I was doing my work in College of Management Science, and I got a Fdp approved by Anna University. It was conducted in Well-Tech, old Well-Tech. Now it is university, and 15 days workshop. It was conducted on queuing theory. And when the order came, I was really very fortunate to have many professors. Professor Thangraj was also there as a guest speaker. At that time, he was the director of Ramanujan Institute of Advanced Sciences. He did not advance mathematics. At that time, he was not with the university, but he was a director there. And he came all the way, 3 days. He gave lectures on queuing theory, and Anna University professors also came. 15 days workshop, and it was a great opportunity for many teachers, and many teachers have benefited. I am very happy that this workshop is being organized here in Well-Tech High-Tech again, with a lot of efforts taken by Rangarajan. I think Rangarajan took a lot of interest in mobilizing guest speakers. Nowadays it is very difficult to get guest lectures. You think that guest lectures are just like that available. No, certainly not. Very difficult. And in spite of all the difficulties, Rangarajan took every step in calling professors and getting their consent. I think that he has got sufficient number of speakers for this 7-day workshop. Mind you, 15 days workshop is very difficult. 7 days is also very difficult. And also he has made many calls to several engineering colleges asking the faculty to attend this program. I don't know how many of the faculty are attending this FDP. This FDP is on transforms and partial differential equation. As Professor Thangraj has rightly pointed out, why these transforms and partial differential equations are put together is really very nicely framed. Transforms, it's a different idea. Partial differential equations, it's a different idea. Why these two concepts are put together without, you can solve partial differential equation without transforms. See, you can solve partial differential equations without transforms. Similarly, transforms can be studied as a standalone subject. Now the two things are put together to make that transforms can be used to solve partial differential equations. It's a nice way, a compact way to get analytical solutions. Transforms are needed. Partial differential equations can be solved numerically also. Nowadays, you got a lot of packages available. Mathematica, MATLAB, many things are available. You need not solve any equations. You can just type in the equation, the package will deliver the solution immediately. You need not put all your analytical skills to solve the equations. Such things are not already available. But still, this paper, transforms and partial differential equation, should be taught to the students because it will develop the analytical skills of the students. The subject is intended to create and develop the analytical skills in the minds of the students. Usually, I have seen from my experience, the 11 years of engineering college teaching experience, this M3 paper is found to be very difficult to the students. They will pass M1, M2. Even they will pass queuing theory, numerical methods, statistical methods and all. But M3 will be a burden on the students. Because there are 5 units. The first unit, second unit they will study well. 5th unit also they will study well. The third and fourth, partial differential equations, applications of partial differential equations. These 2 units the students always find difficult. This we have to make the students to be very easy over it. See, thing is, we don't teach subject from application point of view. If you start teaching the subject from application point of view, perhaps the students will be able to appreciate the subject. You simply go to the class, straight away start wave equation, one-dimensional wave equation, right? Dou square u by dou t square is equal to c dou square u by dou x square, c square into dou square u by dou. Simply write, this is the wave equation. Student may not appreciate the equation. Why it is called wave equation? The modeling part of it you don't teach at all. How the equation arises. The modeling should be included. The curriculum itself, there should be a awareness of modeling. But unfortunately, the curriculum lacks the modeling aspects. Not that I am a model builder. Say as our principal has told, I am more involved in modeling only. If you give any problem, I'll always think of a problem from mathematical point of view, how to get the problem as a mathematical equation, model builder. See, modeling aspect should be taught to these students. Although it is not in the syllabus, as a teacher, whenever I am giving this opportunity of teaching M3, first of all, when I do the fourth unit contains wave equation, heat equation, Laplace equation, only three things. When I teach heat equation or wave equation, I first of all derive the equation. Take a string, how the wave, the longitudinal of the wave arrives. Derive the equation. Then only the student will appreciate the importance of mathematics. Otherwise, simply mathematics will be boring for the students. Similarly, heat equation. How the flux comes there. How the heat is propagated from one end to another end. How the waves are spread in the plate. All the things are very important from the engineering aspects, provided you teach them from engineering point of view. You don't teach them from mathematics point of view. As a mathematicians, we appreciate the subject, but as engineers, we have to make them to appreciate the subject. Without doing those things, mathematics will be, as our principal has told, they will run away from mathematics. They will not come near to us. Today morning, at 8:30, one student peeped in my room. Sir, I have a doubt. I was getting prepared for the workshop. So he peeped into my cabin. Sir, I have a doubt. What doubt you have? I have exam at 10 o'clock. Today, amount paper, arrear paper. Amount, sir, arrear, sir. I have a doubt. What doubt? I know. He was my class student. He never wrote anything in the class. His notebook will be empty. I was really very angry. See, this fellow did not write anything at all. Whenever I go around the class, I used to see. He will never write at all. He will simply sleep. I wake him up, write something. No, sir. I was preparing for IIT. I did not get a rank. So this year I am going to appear again for IIT. So next year I will be joining IIT. Very good. But this year, he is having a writing arrears. See, such aspirations should be there with the students. But the capability should be assessed. What doubt you have? We got, sir, differential equations. What is differential equation? Variation parameters. He brought a book. So this problem I want to do. You know whether this problem is going to for the exam, come for the examination? Do you think that this problem will come for the examination? Yes, sir. This problem will definitely come. How will you know? I saw the question paper, sir. All the 3 years the same question appeared. For the past 3 years the same question appeared. Y double dash plus y is equal to cosecant x. For all the 3 years, the same question was there in the question paper. So I expect the same question will come this time also. Okay, fine. What is the method? I taught in the class, not from the book. I gave algorithmic way. First step, second step, third step. We have the solution. You remember the steps? We did not write the notes at all. How can you remember? And I told him, see, this is the way. First you get the auxiliary equation. Next you write the complementary function. It will have 2 independent solutions. You call them as y1 and y2. Once you find y1 and y2, find Wronskian. And once you find the Wronskian, this is the solution. You find u1 and u2, then the solution is given. For only 4 steps. He worked the problem before. See, the same thing I taught in the class, he was not able to write even a single line in his notebook. Now 10 o'clock he is going to appear for the examination, and he peeped into 8:45, he wanted to solve the problem. See, as a teacher, I kept passions. Because he did not write, I could have got angry on him, but I did not. See, nowadays in the students' mentality, you have to actually adjust yourself. Because of my 47 years of experience, I did not get angry with him. Otherwise, youngster, definitely you will bombard him like anything. Therefore, as a teacher, I advise myself and also you to have patience with the students and teach them in a simple way. You may know the subject very clearly, but teaching to the students is a different job. It requires a different skill. Not all will become good teachers. I am telling you, not all become good teachers. Only few will be excellent. I remember in 2002, 2012, when I was given the opportunity of taking first year class. 2 sections are given to me, section A, section B, computer science, section A, section B. And the first semester I was handling 2 sections. Second semester, our chairman, the senior professor, we should not take two sections. He was going around the university. He was seeing that first class I took, second one also I took. He said, why you are taking 2 classes every day? Sir, I wanted 2 sections. No, you should take only 1 section. So next semester he was given, I given only 1 section. Section A, section B. I was given section A as a senior professor. Section B should be allotted to some other professor. And the section B students wanted me. So they said, no, we want only Udayabaskaran to come to our class. Section also wanted me to go to the class. So what I should do? I left the choice to the students. And the principal appointed Kavita, of Weltech High Tech. I remember still the evergreen memory. Kavita, she is here, she is there. She was allotted section B, and provided she should satisfy the appreciation from the students. In fact, she did well, and she produced percentage result higher than my result. I think she produced 87.7. I think, whereas I produced only 81.3. I remember. So such good teachers are in Weltech High Tech, sir. Principal sir, such good teachers are here. I wish this workshop will give fruitful results after 7 days. As Professor Thangraj has mentioned, this will create new revolution in the annals of Weltech High Tech. I wish you all success. Thank you.
Now I call upon Mr. K.A. Niranjan sir, Associate Professor, Department of Mathematics, to give away the vote of thanks.
Present here. Thank you for this opportunity. Thank you for our management, great management, and then our principal sir, and the guest lectures given by our chief guests and our HODs, as well as co-colleagues, as well as students of our colleges, and then our overall team, technicians, and the comparing team. Thank you one and all. Okay. Thank you for this opportunity. Thank you.
Right. So focus on something. So the first half an hour I have to be very general mathematics. Rather it is going to be on how we have to enjoy mathematics by seeing in and around things it does. The next half an hour I will take the hardcore mathematics. Okay. Reflects active will, contemplative reason, and the desire for aesthetic perfection. Why for aesthetic perfection means even when you want to take any decision at home, when your brain is trained by using so many calculus problems, so your brain is automatically trained to take decision. So a mathematical wife or mathematical husband taking decision is entirely different from other people taking decision. They know how to take quick decision, and they will take in a methodological way. They will think twice when you take any decision. There will not be any hesitant to or very rush manner they won't take any decision. Everything will be analyzed logically. Next. Look at this. You know very well what it is. Sudoku. When you solve one Sudoku one day, that will be good. Even if you don't succeed, don't bother about it. You fill up squares as much as you can. It is not necessary that you have to succeed, right? Nowadays it is available even in our smartphone. You can download it, you can have it, right? In fact, after retirement, that is my hobby nowadays. Every day at least I will solve one or two, right? When you solve it, immediately they will give the harder problem. Another time the hardest problem that where I cannot solve it, I leave it. But when I again open it again, that the same problem will come. But the smart one will not leave us unless you find the solution to it. Right. Now, there are so many Sudoku puzzles. Can you read out the number, what it is? It's very difficult. That's a huge number, right? So many puzzles are available. But here also there is an open problem. Is there a puzzle with the 16 starting entries? So it is an open problem. If you are given a 16 starting entries, that you cannot solve the problem. So if there is any one, then you can add it to that. Right? Mathematics is fine. Okay. And then mathematics is challenging. Do you know the Riemann hypothesis? The Riemann hypothesis says all non-trivial zeros or zetas have real part half. That Riemann hypothesis have a very interesting story. Why it is called a challenging means this is one problem we are carrying on from centuries to another century. Okay, and then you know number of primes. In mathematics, two things are always prime composites, vowels, consonants, right? And then reducible, irreducible. And then steady state, transient state. That's what you are going to see in partial differential equation also. Transient state and steady state. And the same thing you are studying stochastic process also. Right? And then prime number and composite number. The next thing is counting. How many primes are there? And there are number of primes is infinity. It is well given proof by Euclid himself. And then next problem is, given a point x, up to that point how many primes are there? That's the next question. From minus into plus infinity, it is infinite. Prove, over. But up to given point, how many primes are there? So that is what the counting principle. In fact, the counting principle is the first device or first mathematical problem that we do. That's why we used to train or we used to learn first counting process. 1, 2, 3, 4, 5 like this. Counting process. Because now we have the number and then we have symbols and everything. And those days they don't have any symbols. And they have used pebbles to count the number of sheep in a flock of sheep. Okay. And then he will take always the number of pebbles along with him in a bag. So when all these things are assembled and when we want to put it in a fenced cage, then he will put one by one, another one like this. So counting. If that one pebble is extra, in this way that means one sheep is missing. If we get more than one, then an extra has come in. So this is how the counting process started. That is why the word calculation comes. Calculation means pebbles. Okay. Therefore we have calculus. Right? We have two types of calculus, differential and integral calculus, because Newton was asked to give solution to two problems by his teacher Bohr. One problem is finding the tangent to the curve, the other one is finding the area under the given curve between A to B points. These two problems led to two different branches of mathematics, namely differential calculus and integral calculus. Okay. So this counting process is such much very much important. So in this counting, the counting process, they want to count it, number of primes, that's called prime number theorem. So the prime number theorem is the very fundamental theorem in the number theory, and Riemann was trying to give his own proof of prime number theorem. So in the course of giving the proof, he has given a function called zeta s. Zeta is nothing but summation 1 by n to the power of s, where s is a complex variable. But originally in your class sigma 1 by n power p, you are all teaching series and the sequences, you know, the series 1 by n to the power of p. It is as a prelude to understand what is the zeta function. Okay, where we are taking that p is a number and it is 0 to 1 what happens, and then when p equal to 1 what happens, and then greater than 1 what happens. Convergence and divergence you used to study. Okay, right, that is nothing but instead of p is a real number, when you take s as a complex number, see, or p as a complex number, it becomes a zeta function. That zeta function, and then the Riemann was giving the proof that the zeta function so this zeta function has non-trivial zeros which is parallel to y-axis. That real part of s is equal to half. That means it is parallel to y-axis, the line real part of s is equal to half. All the zeros are lying in that line. That is only the guess made by Riemann. And then in the paper, 8-page paper, yes, it is stated that I am not going to prove this. If I prove it, my attention will be diverted. Therefore, I assume that all the zeros lie in the critical line, real part of s is equal to half. Okay, if that is the case, suppose somebody disproves this assumption, and therefore people assumed, after that people wanted to write papers based on that, and later on it is called the Riemann hypothesis. So that's the Riemann hypothesis. So it is a very challenging problem, and we are carrying on from 19th century to 20th century. Now we want to reverse it. There is no solution. That is why when Hilbert was attending the 1900 meeting, International Mathematical Union, Paris, one newsman was asking a question. Suppose a guy, God is appearing before you, right? And then he wants to give you some boon to your life. What would be your first question? Right? Hilbert was mathematician. If I get up from my grave, I'm lost. Is that Riemann hypothesis settled? No, there is no answer. Till then, until we are here. Suppose somebody disproves this, what will happen? 70% of mathematics you have to throw it to Bengal. So much mathematics have been developed so far. Okay, so it is mathematics sometimes very fun and also challenging. Mathematics is beautiful. Beautiful, you have to put it in inverted commas. Mathematics is beautiful, then still you have to put it in what is beauty, you have to define it. Mathematics you have to define, and then you have to give example, right? Definition, the example, theorem statement, and the proof. That is mathematician's job. So mathematics is beautiful means what you meant by beauty. Simplicity and deep idea, that is defined to be beauty of mathematics. That is the equation for beauty of mathematics. So here the very simple thing is e for I y equal to -1. E is one creature, I is another creature, y is another mathematical creature. All the three creatures combined together giving a number -1. And when you take it left hand side, +1 equal to 0. So again, you have the additive identity as well as multiplicative identity of real numbers. So that is the wonders of this problem, right? That we can call it even a wonders in mathematics, this Euler formula. The next one is V minus E plus F. That's also again due to Euler. Vertices, bases and edges. For a regular polygon that we can inscribe in a sphere, there are only 5, right? And that 5 protonic solids. The 5 protonic solids, when you apply this formula, you will get the same result. Okay? But irregular polygons and polytopes, when you construct, there are 13 Archimedean solids. You have different names, okay, combination of this and that. Okay, we will not go into that. So, mathematics is beautiful by just looking at a simple formula without deep meaning. And then mathematics is present like Raymond's music. When you look at that same zeta function, 1 by n square, when s is equal to 2, sigma 1 by n square is zeta 2 is nothing but the value is pi square by 6. Wonder beyond wonder, beauty beyond beauty, we can call it. And then here, when you take n to the power of 4, it has some value, n to the power of 6, it has a value, n to the power of 8 is value, but odd values, n cube, n 5, n 7, n power 7, no answer. So it's an open problem, okay? First of all, whether it's a rational number or irrational number, that also you have to prove it. You will get a paper in number 3. Okay? Fine. So, it is a pleasant, like music, Raymond's music, that musical code is nothing but Yahoo. Right? Fine. Mathematics is confusing, like walking in a dark. Right? You cannot find a black cat in a dark room. So sometimes mathematics is like that. The only thing is you have the ability to analyze that, or you have to feel that there is a black cat in the dark room. Fear that the ball and the bat cost 150 in total, the bat costs 100 rupees more than the ball. So the weddings will always confuse. The fear of mathematics is created by problems like this in the young age. If you teach this, the 4th standard and 5th standard students, when they put problems like this, they are highly confused because of the wordings. That is why people, even schools, it's called a word problem. The word problems are finding it very difficult. That is where first fear of mathematics started. Right? Now here, there are many ways of solving this problem, 25 and 125. Right? Because the difference is 100. Fine. So like that, mathematics is confusing. Mathematics is easy to pitfalls, like a gap in the proof. You take a paper, you cannot put all the proofs that they will jump from one step to another step. But filling that in between them, it will be like a skeleton. But you have to separate flesh to make it a beautiful proof. So that means many papers contains, sometimes you may not understand what they are telling. Such type of gap will also be there. So mathematics is with the pitfalls, like a gap in the proof. Mathematics is uninteresting. You are telling the student is not at all writing anything, he is sleeping in the class. That is uninteresting. He finds sometimes mathematics is uninteresting. Sometimes he is snored in the class also, right? Disturbing others. Fine. 8 wonders in mathematics. First wonder is E equal to mc square. Energy and the mass. You can make electricity and this area also bombs using this formula. Formula can be used for both. Which one? Yeah, it is. That is why you are given a Doctor of Philosophy in mathematics. So this is one equation which is a wonder in mathematics. And then F equal to ma. This formula that you are going to use it in your derivation of partial differential equation for morning I was telling about the string, rod and plate. There you are going to use this law to derive the partial differential equation, right? And that is why it is considered to be a wonder. Another wonder is when you have the 2 planets and then the distance is r, and then using that gravitational force, the F is equal to G m1 m2 divided by r square, then inverse square law, right? That's also another wonder in mathematics. This is black hole entropy. The black hole entropy has given. I think our Indian scientist and Chandrasekhar has studied a lot about this black hole. And then this is another wonderful formula, namely it is an information, measure of information. H is equal to minus sigma p log n. See, we teach mathematics, we teach discrete mathematics. Morning, just now also talking about discrete mathematics of people, they went on modifying the content. I know this is one of the important formulae in mathematics. Why? Suppose I want to pick a number from 0 to 7 and then I want to send it confidentially. How many bits of computer I have to take? That's the question. I want to send a secret message between 0 to 7. How might I do that? So I want to design a computer with what is the memory, right? When you write that 0 to 7, you convert it into binary. 7 you can write it as like this, right? And then you can write 0. You can write 7, 6, 5, 4, 1, 2, 3. This is nothing but 8 forms. Choosing one number means all are equally likely, therefore the probability of choosing one is 1 by 8. So now your h is nothing but summation minus pn log pn. This is nothing but summation with the negative 1 by 8 log 1 by 8, and then the summation is also 8 terms. So this is equal to 8 by 8 log 1 by 8. So this is nothing but minus log 1 by 2 cube. So this is equal to, of course this is base 2. So you have only 3. 2 power minus 3, the minus 3 comes minus 3 minus minus 3 times and you will get 3. Therefore, I have to construct a computer with 3 bits. And this formula carries the information. That is why it is an information measure, and that's an information entropy. Shannon's information entropy. And this is another wonder in mathematics, where the entire digital world now it is working on this formula. Whereas to design a computer, whether it is a 4-bit computer or 16-bit computer, now we are talking about 32-bit and 64-bit, based on only this one. Okay? Because we want to encrypt message at that, we want to convert into that, how it can store it. That is what only mathematics. And you know, in Germany there is an institute of industrial mathematics. When you want to design a chip board, then they have to send it to that institute to give a final approval. And that institute is full of only applied mathematicians. Only after that, because you might have taught that minimal polynomial concepts using gates, right? All these things are applied there, whether the gates are perfectly embedded in that board and everything will be checked by that institute. Okay. Fine. And here, this is another Maxwell equation, of course. First 2 equations dot and next 2 totally. Because this is a combination of both Gauss and Maxwell. One is for magnet, another one is for electricity. And combining both, if they get a formula of 4 formulae, this is electromagnetic thing, right? This is nothing but the cosmic dance of Lord Rangarajan. Because the movement of these ions are nothing but movements of planets, controlled by these 4 equations. That is why it is considered to be another wonder in mathematics. And then 7 Schrodinger equation, and of course this partial differential equation, we are not studying it actually in our course, but this is another important partial differential equation for which you have solution only for 2 dimensions. You don't, it is still open for 3 dimensions. Okay. Then Euler formula, which I told in the beginning itself. Let us begin with an inspirational tool with Euler. We know what is this problem, bridges of Königsberg bridge. So the bridge is converted into a graph like this, and the question is number of in and number of out, or there will be a path. The number of edges meeting at every vertex must be even. Euler said there is no such path. So the new concept called topology was born because of this problem. Okay, you know very well about the bridges problem. Then the nature wonders is alive with the beautiful and amazing shapes. Just I am going to show you how in and around, when you go to the garden, then hereafter your look will be different. How many nodes are there? Whether it is going in the right hand direction or it is going in the left hand direction. And then why that all the leaves are getting sun rays, and then whether they are horizontally in one row or but they are 120 degrees spaced leaves are automatically naturally coming out, so that sun rays will get equally. There is a natural thing will happen. That is in Tamil they call the pachayam. I mean, when you want to have that habit for all the planets or the plants, that naturally all the nodes are created by God or created by nature, right? If you think God or if you think nature, whatever it is there some mathematics. Look at this. Is there any mathematics in the shell? Right? People may wonder that why it is of this shape. And then the flowers, there are so many flowers, and then are they from any pattern? There is ancient people held this number in our reference and they gave it a name like a given proportion or golden ratio. That golden ratio is in our hand, in our fingers, in our hand, and then even in their body, right? And then height, there is a measurement. When in the case of ladies, how this length between these eyes, nose, there are so many ratios are there in the face. You have a beautiful face. So how many proportions you can have to have a beautiful lady or a beautiful man? Okay, all these things are given by the wonderful number or wonderful ratio, namely the golden ratio. And then those days in Roman architecture, you can see all the buildings they will use only golden ratio number. Even the entrance, windows, everything is made up of golden ratio. Right? It's useful for civil engineers. The golden ratio concept is nothing but civil engineers. It is nothing but your Fibonacci number. The Fibonacci number, 1, 1, 2, 3, 1, 8. 3, 8 you can have that window or the entrance. Okay? So that is where Vastu, that's what we call it Vastu. Vastu is nothing but Fibonacci number. Right? When you take the ratio of the Fibonacci number, it converges to one point. That point is nothing but a golden ratio. That will satisfy one quadratic equation, and the solution of the quadratic equation will give the golden ratio. These structures have that golden ratio. Now look at this Leonardo da Vinci and Mona Lisa. The drawing has that structure, right? It is called a golden triangle. And then you know what is this? Last Supper they call it. And it has this painting has that mathematics. And it is found in many places in nature, flowers. So what is this number? Now, father of geometry is nothing but you know that there is only one place where you can find the Euclid statue, and no other parts in the world you have that Euclid statue. The dividing proportion is you have this x, I think this is considered as 1 unit, x plus 1 divided by x. Given that entire point, then this portion is x plus 1 divided by x. That is what? This x by 1 equal to x plus 1 by x. Longer part divided by shorter part. Whole thing divided by the longer part. So x by 1 and then x square equal to x plus 1. And then when you solve this, you will get golden ratio. That is 1 plus or minus root 5 by 2. And when you take that positive number, that is going to be 1.6 something. And what is the beauty of that number is, when you subtract, you will get that wonderful idea. Namely, say x square equal to x plus 1. See, now that when you square it up, because x square equal to x plus 1, and this x is a golden ratio number, it's nothing but when you are adding this number, that the square of this number equal to x. Right now you can check in your calculator or in your smartphone. You will get this x square equal to x plus 1. And when you subtract, what will happen? X minus 1 is nothing but 1 by x. Again you will get this 1 to the power. So no other number which has this power. And this number is so important, it gets its own letter, namely phi. Phi means Philos. The man who was used in the constructing, he is an engineer in Rome. So this number is named after phi. Okay, 1 by 5 equal to 5 minus 1. Then 5 square equal to 5 plus 1. 5 is geometric 2. Golden rectangle. Square and smaller rectangle. And then 5 is approximately 1.618. Like that, when you take this length and this, and then from this taking this, and then you divide this. Like that, when you go on do this, you will get now you remember the shell sphere which I will show. So that contains a golden ratio by nature. And this is called a golden triangle. All our steps must be 36 degrees slope. Then you will not have any pain in the hip. But no engineer follows. In well-tech it is highly, the losses step is very high. It should not be. Losses step must be very small. On the other way, where the first step from the floor is very less, but in the last step will be very high. That should not be the case. You've been to Kaskasta, and there the steps are very beautifully arranged. Length is higher, lower, like this. Because when you go up and up, that country is a very cold country, minus 19, minus 20, like that. So you need more oxygen. So when you go up and up, it should not increase the height. You should reduce the height. Therefore, intaking oxygen will come. Otherwise, you will be in trouble. Breathing problem will come. That is why aged people will get breathing problem when you go up. But if the steps are arranged in a very nice way, in small steps, then you will not get it. Okay. So mathematics helps, namely the golden angle, 36 degrees they have to use to construct the step. That is a Philos geometry. I told you that in the beginning itself, how these old buildings, Roman buildings, have these golden rectangles. He is named after Philos. Now this is golden triangle, Mona Lisa. And then her face is, there are so many such drawings will have this golden ratio concept. All architectural buildings, paintings are knowingly or unknowingly they have used that golden ratio concept. And that is why they are this long standing. When you take the body and then fingers, they are also in golden ratio, 1.618. Now look at this distance, A and B. That's the golden ratio. Distance from that and then breadth, height. There are 22 points. From this, you take the ratio, 53,130 ratios are there in the face. And if all these things are if 1.618 and men means the entire height from bell bottom, from this one point up to this. When you divide this, it should be 1.618. Maybe M.K. Tyagarajan might have got it. That is why he has got all the 64 amsas of that man. Right? And here, there's a Leonardo da Pisa. Now I will quickly, because this, we all claim that contribution of zero it is by Indians. That is the written document. Written document is not given by Indians, it is given by the Fibonacci. Fibonacci has in his book, that Avadi, the book of calculating, in this book only that he has mentioned that Indo-Arabic figures. There that contribution of zero he has mentioned. That is why still we claim that zero is contribution from India. Otherwise, there is no other place in Indian culture, this and that. There is no record showing that the Indian contributor is zero.
am an Indian. I believe. Because I avoid a lot of views.
Right, in the same book there is a problem called the rabbit problem. From that rabbit problem alone we got that Fibonacci sequence. That is why in computer science first they will write how the computer produce Fibonacci numbers. And they will write a program, and then after that at certain point of they will get negative numbers. Right? He don't give you that all Fibonacci numbers. You need a different logic to write exact Fibonacci numbers. Because everyone has an integer overflow will take place. Because of the integer overflow you will get negative numbers. Okay? So we think that adding two positive numbers how you are getting negative number. So computer has also its limitation. First of all you must try to understand the limitation of the computer. Therefore you need actually they need three steps. What they will A, store one place, B, store one place, and they will use another C to interchange. Right? And then they will write to B and C. Actually there were three memory places to write a program here for generating Fibonacci sequence. It is not necessary. It is a two memory places here. You put A equal to A plus B and B equal to A plus B. That's all. Because of the computer technology, computer addition is different. So there, this will give you, when you print it out, you will get all the Fibonacci sequence. Okay. Right, not necessarily three, you can have even two. Fine. This is a rabbit problem, and rabbit problem alone created this Fibonacci sequence. And then B's family, again we are getting that Fibonacci sequence. Okay, now I told you about something about the golden ratio as well as the Fibonacci. What is the connection between these two? When you take the ratio, right, 3 by 2, 8 by 5, like this, that ratio will tend to 1.618. That means the ratio of Fibonacci tends to golden ratio. So we are talking about so many mathematical ideas. These ideas are coming from nature, in and around us. That's what I want to try. So, as Professor Udayabaskaran told in the morning, you have to model it. Unknown quantities, that is why we teach algebra in the primitive process. Unknown quantities put X. That's the first abstract idea we have been taught and we are teaching also. So this unknown quantity we call it X. It is starting from as long as you learn algebra. Right? That is where people sometimes understand, sometimes they don't understand. That is where the problem starts again. Fear of mathematics starts. Word problem and then abstraction. When you give more and more abstraction, then the problems of difficulty level will also increase more and more. Once you enjoy this abstraction, then the mathematics will become so easy, and the teaching as well as understanding, the reading, studying, doing, everything will become so interesting. Once you put your mind on the lines of mathematical lines, then if there is any gap, how they try to fill up that gap. That's another challenge. I think I skip all the slides because these are all going to tell you different things. And then here is that ratio is approaching this ratio of Fibonacci numbers converging to 1.18. Okay. Let's skip.
Class on this topic, latex. How to use latex for the papers? I mean, a thesis or any other papers for. There is clearness in the symbols as well as the easiness to learn this subject. Okay, I mean, here we have many editors are there. Many editors are there. One of the editors to learn this one is text. That means latex. So HTML, that means that those are body language, coded languages. Okay, HTML, XML, RTF, those things. These are editors. Okay, to see in our websites all the things. And the text is this one are written by the Donald. And then in 70s itself they came into the field of the computers. Okay, what is the use? Okay, what is the use of this latex as well as word processors? Okay, there is quality for if you want to maintain very best qualities of the editors, we have to learn this latex. Okay, high typeset quality, easy to include math formulas, and then good for the large documents, minimize the document. Suppose we are going to type it in the word, means that we take many pages as well as the document size is more than this latex. This is going to convert it in terms of their PS, PostScript or otherwise, that is going to be transferred into PDF also. Okay, both things is possible to take out the printouts, or you may use it for the papers. One is the PDF, other one is using this PS, PostScripts. Okay, so that is document size wise, clarity wise, quality wise, we are going to make use of this. Okay, editor. Here is that is drawing is something is going to be for some. If we have more practice, that we are going to have it some easy to draw that diagrams. Always we have to start with initial only. So the difference between them. Okay, this one is the word and this one is the latex. By seeing both the editors, this will give you the more clarity than this word. Okay, that is comparison between the latex as well as the word. Okay, we know already word. So, but we are going to if you are going to insert any picture or in any symbols, initially we will struggle with this latex, but this will give you the more usage for these things. So later on, this will give you the very easy to learn this one. The next one is if you suppose we want to learn latex, means we have to install these things. Meeting center, LED, these are all the objects that make. Those are all editors. These are all the editors. This is the main one, we have to install it. So these are all available freely in the websites also. Meters. And then this one is the WinEdit, one editor. Free editor. This one is a text center. I am using this one now. And these are advanced one. I am not using this, but this one is coming for me to make any purpose. So these are all the things that we are going to download. This is 2.9. I am using it now. This is the technique center. This one is 1.2 MB. One is small one. This one takes 400 MB nearly. But that package is that one is RAR file that is going to be extended to near 2 GB RAM. 2 GB RAM speed we should have it. Then only it's easy to run the programs. Next one is this one is latex one, and a compiler is there. Similar to our C language. C language we are writing some programs and then compiling and then running the things like that. Similarly here also we have running editor is here. This one is one editor created text file. So similar to our word only. So simply but starting with some lines there, command lines. So we have to make use of it, otherwise this will not help us to create the PDFs. And then compiling and then build your document using the latex program. Display result document PDF as PS or DB also. These are the viewable outcomes are here. These are all the outcomes. PDF and this one is PS. Some papers are asking in this format. So in PDF I want it as PS. Some papers are journal papers are asking in this format only. Some standard journals. Next one is some of them are here. So what are the kinds of the classes we are going to do it in this latex editor? So first one is article. So 1 or 2 pages means maybe use of the article. Report means some pages more than the articles, and then a book means more than 100 or 1000 pages like that. Okay. And the next one is we are using some other packages. So additional functions. So these are simple things. Make use of the simple symbols like that. But if you want to make use of the graphics, suppose the XY line like that, means we have to make use of these graphics. Extra packages. Hyperlink means reference. Okay, suppose we are going to click somewhere else, that will show you the corresponding places for the. So these are the main body and then the bibliography reference. These are the options only. Bibliography means we are going to say about something about the staffs and authors, some other references like that. Main body we are going to make use of this already one. That is bigger document end just on the starting and ending of the. Okay, these are the options. For first one is the article. How to define? This one is the first line of the any PDF formats. Document class, these are options. Usually that will give you using that 12 size and the A4 size. Suppose if you want to make it of the A3 also that is possible, as well as A5 also possible. Size of the paper. Discrimination of the papers we are going to discriminate here. Article means small number of pages. Book means many number of pages like that. Letter means simply 1 page or 2 pages like that. And thesis means 20 or 120 pages like that. So based on the activity papers, so yes, where articles. Okay, these are the things. Document class. Starting with these lines. These are basic thing to learn the subject in the LaTeX. Okay, next one. These are all the options. Those are the points. What is the size of the font? 10 point, 9 and 12. A4 paper size, and then like paper and 1 column, 2 column, 3 columns also possible. 1-sided or 2-sided, that is based on the adjustment in the columns, in the indent of the papers, printing pages, landscape also possible. So those are the packages we have to include for the landscape. Okay, document. This is the one of the example for this one. So that is document plus with the size of the font is 12 and journal. Suppose we want to make use of the here is okay, here you are going to use the book also possible. So not here. Okay, next one is so general format. This one suppose we want to use if we are going to include any package similar to graphics or any other things means multi-column. These are some of the packages. At a time we can include all the things, otherwise some of them are going to be, you can use it at a time, otherwise separate for rows we are going to include it. This is the usage of these packages. So next one is IEEE package, these are all the things. So next one is the basic LaTeX. Okay, to learn the LaTeX means begin document. Before that we should have that document class. Document class with the options to whether that what kind of article that you are going to do, either book or by the report or article. Based on this, so we are going to document this. Start with this, end with this. Before that, we should have that begin document class. Okay, what kind of class that we are going to take, either book format or article format or report format that we are going to include here. First line, next line should be here. Third one. Before that begin document, we should have some packages. What are the packages that we want? So suppose if you want to reference means packages, graphics, all the things means we have to include before this begin document. Okay. Next one is these are all the things. Like what are the things? Basic things in Word means we are going to enter. That means next line will come. Similarly here is double line or new line. Or new page means next page. That will go to the next page. Next one is bold the font. That is like this. Text BF. Within this we are going to use some font here, that is going to suppose VTST if you want, that is going to comes under bold font. This should be in the, and then BF also possible, that is general for the entire document. Okay, next one is emphasizing these things, italics. Italics means lamp, in the word that will control I, here is control B. Similarly here is enter. In word, similarly here is some of the alternative things in the LaTeX learnings. So underline means like this way. Okay, there we are control U, we are using the shortcut for this here. This is the thing UL. So anybody using this one already? So example, suppose we are going to use the document as article is 1 or 2 pages, that's all. So that means bigger document, imagination is one of the sentence we are going to use it here, unit document, that's all. That will give it like this. This is in the PDF format. We may mention this before that one column is there, that is how you are going to produce the outcome. That is PDF or PS or DVA, 3-4 formats are there. How you are going to make use of this? That we are going to based on the running in the control FI is there. That means that we are going to run this code and that will give you the output like this way. So for this line, this is the one output of this one. So next one. So title means title of the paper. You can make use of this. Okay, that is like this one. And then make title and then author you can mention here. And then this is the paper names, all the things. I will be like these things. And the abstract it comes under the command. So begin, end. Begin document, end document. Overall document is begin document, end document. Within that we have like this. Begin text, abstract, end abstract. Within that is abstract, that will give you like this way. So this is not going to, you are not going to write here, but that will come automatically here. So because this one gives you, this one is one command that will give you like this way. So remaining things as series that we have here. So next one is chapter. Chapter means similar to our unit 1, unit 2 like that. That means mechanics or mathematics unit 1 like that. Section means that means in that one suppose first unit means 1.1, that is first section like this way. So 1.1. Subsection means 1.1.1 like that way. So no need of giving all the things number ones, that will come automatically under this chapter. Suppose next one if you are going to give chapter means that will going to give you unit 2 like that. 2 and then that will comes remaining things are comes under this chapter only. Chapter is the base one and then that is number 1. So our second unit is 2. Third unit, like that, suppose for our runners, the syllabus is 5 chapters are enough. We have 5 units. Each one we have some 4 or 5 topics, main topics that will come under this sections. And under that some more subsection means that will come under like this. Under that some more sections. Under section star. Star means that will not give you any number for that. That's not going to give simply okay without any number. This will give you, this is chapter 1 means 1. Suppose unit 1. So okay, this chapter, suppose it giving what is the PDE. Suppose PDE means partial differential. First unit means number 1 and then okay space and then partial differential equation. First topic is we have it like that formation of the PDE. Here we are going to give it formation. Okay, here a section within it we are going to give the formation of the PDE means so that will give you the number as 1.1. So under the subsection means here we have 2 ideas as per partial differential equations. So one is going to be formation of the PDE by elimination of the okay arbitrary constants. That is first subtopic of the main topic formation. Second one is subsection. Okay, under that we have second one is that is going to be okay formation of the PDE by elimination of the arbitrary functions. That is one second topic. That is 1.1, 1.2. Okay, this one is 1.1, this one is 1.1.1 and 1.1.2 like that. This one is suppose we have more material, that means subsections also we can include here. This one is not going to give you any numbers for that. Simply give you the any number. Suppose some topics are there, suppose that is not mentioned in the analysis means make use of the star. Star will not give you any number. But that will give you okay in your reference page in the index page. Okay, next one is font sizes. Okay, based on your 10 point or 11 point, 12 point, this may change this according to the point size. So this is smallest one, tiny, and then this one, this all the things. Largest one is huge. One more is that according to our space adjustment, we have some more things are there. Selection font wise. That is one more thing is that is not here. I am not mentioning here. But one more thing is that according to our okay place adjustments. We have just this one more time is there is selection according to the font size. Okay, mention the font size as well as the line between the gap between the 2 lines. That is also mentioning, that's also possible. Okay, and the item is, what is the use of the item is? Sometimes we are using this star, bulletins, all the things. That is to emphasize some of the topics point wise, number 1, 2 like that. Here some 2 stars are there.
That means like this way, but how to mention this? This is the output, this is the how to use negative. So before that we should have document class, begin document, and then all the things. So ended with the end document. Before that, what are the things that we have it? So this is the nothing but begin item is item. Here is dot text wants text like that. This is going to the output for this. This is the one of the. So this one is enumeration. Enumeration is that will give you this. Enumeration is number 1, 2 like that. Numbers. No need to put 1, 2. That will come automatically. How many times that you are using these items? So first item will give you the 1, second item will give you the 2 like that. So similarly you can go according to our requirements. So enumeration is like this. Before that one is only dots will come. Similar to our star or bulletins or like that. So numbers means is the next one. Numbers means 1, 2, 3. Here also if you want some other adjustments means we have like this. So this is the one. So here, suppose we are mentioning within the square brackets. So 1 dot. Suppose we want to start with 2. Start with the 2 means square brackets and within brackets 2. We can directly implement it without using the one default. Default is 1. Suppose we mention as per our requirements. Suppose Roman letter 1 or Roman letter 2 like that. So according to our requirements, within that we can adjust all the things. Those are the things that we have here. These are the things here. So this is the enumeration. According to this, our requirement is something else or not as it is default one. Suppose this is going to be our adjustment wise. This is the one first Roman letter. Under that some other things. Under that some other things. So this is the one Roman letter 1. We have to think like this one. How it is going to be 1. So Roman letter 1 within that. So here is the thing. Roman letter 1 within that. Here is now I am not mentioning anything. That's why automatically come that dot. And then here I am mentioning minus. Minus means that minus will come. This is the ended. The second one is started like this. So description means our description wise we can go for this. So that is going to like this. So item is going to be replaced that instead of the bulletins or by the numbers. Numbering means make use of these ideas. Next one is first right, first left, and centering. Control C in the word that we are making use of the center of the pages. Similarly, control L for left, control right R means that is going to be right side. Control J means that is in word that we know it already. So control J means justification. Similarly, here also we have first left, that means left side of this. So and then plus center means this is center of the pages. So this is the page means this center, this is the right side one, plus right, these are these. So next one is adjustments in the spaces. That means suppose if you want some space, means like this one. Suppose quad means double quad, this one is indent means some 1 or 2 letters gap. And indent means some 2.5. Double quad means QQ quad. QQ quad. This one is simply quad. And gaps in between the words. Suppose sometimes a comma is going to be along with these words. So something suppose if I want to adjust with these things, that is going to make use of this. These are the things. There is slash, some space also, some other adjustments also. Slash space and then slash comma. All the things. Slash semicolon. Colon also is there. Some of them are here. No indent means that is going to starting with the left side of the page. This is the one. And then sums, these are the ones. This is how to define math symbols in the Latin means within dollars, anything if you mention it that is going to be changed to the that is going to as mass. That is changed as like this. So here, this x square that is going to change it as x. So this is English. Ordinary sums or sums means like this way. But this one is like this mass. This one is partial. These are all ordinary things that is going to be changed like this. So color is there. Color is means we have to mention the package color. Color means that is going to give like this slash color. Within that we mention anything like this means that is going to change according to the color. We didn't mention here, but change in this case. So indent means space. Quad means little bit more space, and then double quad means more space than this. Like this one. So some of the spaces are H space is there. Horizontal space. Horizontal space is that give you accurately according to your 1 inch, 2 inch, 3 inch like that. We can adjust the That's anywhere in the lines. That is going to have space. V space is there. That is going to be vertical space adjustments. Okay, any doubts up to here? I got doubts at now. So what are things what we will learn means big text is the basic file that is going to embed into the system. Next one is technique center, that is going to be editor, that we are going to include all the things, that is document class, the begin document, end document. Within that what we are going to type it as is, that we are going to convert it into the PDF, and then that will give you the outputs, and then we are going to take the printouts. Up to that we have seen, okay, up to this we have seen. Here onwards, how to use the equations. Suppose if I want this one, equations. So equations means alpha, okay, like this. Alpha means that is alpha symbol will come. So like this way, alpha, beta, gamma here. And this one, how to make use of this. Suppose in word means we have to include what is that, math symbols or equation editors, all the things we have to make use of this to type all the things. But what is that, clarity wise, this one is more clarity than in word things. Okay, this one is how to do these things. Can you see this? So this one is sigma r equal to 0 to infinity. That means slash within dollar we have to mention, and this will be a error. Okay, slash sum. This one is one mathematical command. The mathematical commands all should come in the dollars. Okay, sum limits. Limits means limits from where? R equal to 0. That is here. R equal to 0 to R equal to infinity. Frac. F-R-A-C slash frac. That means A by B format. So D frac is there. D frac is same as it is. Okay, size of the numerator. Here ordinary math symbols as it is here also same sizes will come. That is a D frac. And then U, X, these are the things. U, X minus R, L. This is the L, the scripted L, like this way, L. And then 4Q, this is a power. How do you use the power? Power for the function. Suppose U of X minus RL minus Q, like this way we have mentioned. Frac means this is the numerator. Frac, that is numerator. Here one more curly braces, within the curly braces. This is the denominator. This is the denominator. Here up to this. Okay, that is going to give you a square root SQRT. SQRT means square root. Within that alpha, okay, suffix is I comma j. Here is we have it I comma j, and then here is square, and 2 minus 2RL. 2RL equal to f of x comma, like this way come delta, capital delta. That means like this way. Small d means ordinary this symbol will come. Alpha, beta, gamma, and then like those things. Small d means. L means scripted L. Underline symbol means that will come the subscript. They like this way. Okay. Okay, that will give you the superscripts. This is subscript. This is superscript. This is the symbol L. And U, K. That is function U of K. Dollar. Within that dollar, we mention anything. Suppose A equal to B means the difference between the ordinary A equal to B and then within dollar sign, that will give you the difference. So like this way, this one will give you the same thing. If you are going to follow like this way means, this will give you the center of the page. Center of the page. This one is left. Okay, without mentioning the double dollar means that is left side of the things. Suppose the double dollar means that will give you the center of the page. Next one is like this way. This one is also equal to this. Similarly here. So the instead of this double dollars, suppose we are going to mention the same commands as it is. Suppose if I output it like this, without using double dollar means this one slash and then open okay square brackets. The same commands slash sum up to this U of K, and that we are going to mention here slash and then close brackets means that the same output will come like this. This one is these things. How do you make use of the symbols? Mathematical equations. These are the equations, but how to use this? When require, as per the requirements of our needed things, we are going to make use of the things. Okay, next one is suppose if you want some numbers. Suppose if I want for this number, I want number 1, 2 like that. So I make use of this like this. That is begin equation label. Label means suppose we are going to click this one, so that will refer to the other places. That is the equations. It's same thing if we are going to mention here also, but I am mentioning here equation, okay, without star like that. Okay, equation without 1, and I am mentioning here tag 22. That is our, as per the requirements of the equation number, I mentioned like this. Tag 22, that will become like this. Without mentioning tag means that will become default start with the numbers 1, 2 like that. So this is the difference between them. So same equations, but if I want to mention, suppose in word means we have to keep on giving tab until that gets the end of the pages, even though that is not going to end with the end of the pages. That's somewhere else according to our okay, that is half page, half inch, okay, spaces is the one. Okay, next one is these are our own descriptions in the things. So we can mention it here. What is, suppose if we want definition number 1, definition number 2, like this, these are the theorems, we can mention it here. Definitions, examples, lemmas and sections. Based on our sections, if we want like this way, suppose VTHD number 1, mention here, VTHD. VTHD means VTHD number 1, VTHD number 2, like that. Our own definitions for the theorems, we can mention here. Suppose example 1, if I want example 2 like this, definition 1, definition 2, lemma 1, lemma 2 is based on this is going to change. Okay, based on our requirements, own requirements. Okay, these are all our own descriptions. Okay, our own changes. Okay, I mean newly you can create. So I don't want always problem number 1, problem number 2 means because of this example number 1, exam number 2, VTST and exam number 1, like that we can mention here means that is going to come as it is for the wherever you for example like this, begin example, end example means this is going to give. Begin example, end example means that is going to give according to this. Okay, EXM is the thing, begin EXM, end EXM means that will give you the written as the PDF files example 1, example 2. But we are going to mention begin EXM, end EXM, that's enough. Within that what we are going to mention it, that is going to be example 1, number 1 for the first one. Suppose second time I mention it like this, begin EXM, end with EXM. Within that what we have it, that is going to be okay, example 2 like that. That is going to change according to our okay, requirements. Connection is similar to like this. Okay, section means Kavali said all the things, applying theorems, like this theorem. So theorem 1. So how I am going to mention it here? Begin theorem. Previously I have given like this theorem. So this is a theorem under section idea. So this theorem, how to make use of this theorem? So that is going to be here. So how to use this theorem is section, introduction. Within that I am using this theorem, begin theorem, end theorem. So I am naming like this way. So this one will be like this, theorem 1.1. Theorem means this theorem is going to be here. I mentioned it here. So like this theorem, that will give you this thing like this. So under this section, this is the thing, this is the theorem 1.1. No need of giving 1.1 here, no need of giving a theorem or this. Wherever theorem, if you ever apply it like this way, mention it like this. Begin theorem, end theorem. Whatever things that we in between the lines, begin, end theorems, what are the things that we have it, that is going to be here under this theorem 1.1. So after this, whatever the requirements that we are going to as usual, what are the as per our requirement that we are going to change after this. Within that, there is one theorem 1.1, 1.2. Suppose we are mentioning here is begin theorem 2 and end theorem 2, there is no theorem 2, here is that is going to come theorem 1.2 like that. So this is the one. The next one is definitions. Definition is previously I mentioned like this. So this is the way. Definition. New theorem, definition, theorem. But how I want to look like that. Definition. This one is under this section. That's why this is the extra one. No need. Okay. Suppose we want to make use of it. Otherwise, no need of this. Okay. Next one is definition. Already you know this how to use the theorem. Next one is definitions. So next one is no need to remind all of which what's the number of the current definition. No need of the that is we may forget also, no problem. But this will keep on giving the numbers automatically. Okay, definition 2.1. Next one, suppose after that somewhere else we are going to mention in that begin definition, end definition, that will give you automatically 2.2 like that. No need of the remembrance of us. So this is how to do for this definition. No need of this. These are the extra things. We want to make use of the otherwise leave. Under the section 1, we are having like this. That's all. Section means that is second section. So second section, first section within the same section means this is going to 1.2. This is a new section. Previous one is 1 and the second one is here. Under this second section, Okay, under that one definition, that's a 2.1 like that. Suppose one more definition for mention means similar to our word also, but there is no need of the requirements of the numbers that will come automatically for this one. General format. Reference means suppose we are going to think somewhere else like this. Suppose we are going to mention here a reference like this. If we are thinking means that will go to the corresponding places. That's the main use of it. Similar to our hyperreference in the word pages. Web pages. Web pages. If we are going to click something is that we are going to give some outputs corresponding to that. Similar to here also we have it like this. Okay, that is the references. If we are going to click these things means that we are going to give some references to the corresponding places. Suppose a DE1 somewhere else. Click this one. That will give you to the definition wherever we are mentioning it. That is going to give a reference to this. Labeling and reference. Labeling, reference, these are the two things. And then general here is we have general formats. So how to mix up these columns? Columns means for tables. Suppose this is the one table. How to start with the tables? How to make use of the table? How to produce tables in the latex? This is one of the important things. So this is the general format. So suppose begin tabular and end tabular is the starting ending. Within that, how many columns that you want? Okay, this is within curly braces. This is the left side of the table. This is pipeline. This is the end of the right side of the table. Within that, how many columns that you want? Suppose this is the first one. This second column. Alignment is there. That is C means center. Okay, next one is R means right, and L means left. All the things. Some more are there. So M is there. E is there. Some other things also there. Within tabular, whatever things would this is the body of the things. So for example, tabular, here is center of this one. This is the left side and this one is the second column. Okay, second left side and third left side. One is left, center, starting column, second column, third column, fourth column. These things and this instead of this, in between two C and L or L and L, in between these things we are mentioning here and symbol. Here first column is serial number, and symbol means similar to a tab. Tab in our word in a table, tab means that will go to the next column of the same row. Similar to here also. So that is going to go into date means second column, price means third one, fourth one is kg like that. So this one is second, that goes to the second row. After that I want some line, H line. H line is this line. And here is this one is starting line, top of the thing, and then one row is over. After entering this next line I am going to here. Before that I want some line, this is the one. And then here is first entry. Similarly here are some entries are there corresponding to the columns. And then here is some double line and then next line that will go to the next line like this. That's all. And then end with the end column. That's all. Suppose if we are going to mention something else in between these dollars. Suppose mass if you want it. Again make use of this. Get double dollars. I mean single dollars, double dollars as per our requirements. So double dollar means that's one center. Single dollar means simply the words, mathematical words. That's all. This is the table. Okay, and then caption like this. Okay, these are the Januaries. So labeling if you want make use of it, otherwise leave it. And then this is the table. Okay, we mentioning the name of the table like this. We mention it, and we end with the same thing, but here is same as it is. The dots means what we used in the previous example. Make use of here, and then these are the things. Make use of this caption of the table like this. The output for this one is here. The next one is example. Okay, we can all I want it in center alignment. Center alignment means there is a multi-column thing I want it like this way. So for multi-column is splitting one. Okay, this is the one. Okay, cell. One cell into this. Okay, two rows. The second row is split into again two columns. How to split like this? So make use of this. Like this way we have to mention it. This is the one. So that is begin three things. C, center, center, center. So that's the thing. Next one is line. This line is here. Next is multi-column. Undecimal means this is going to mention it in two columns. Okay. So the second column I want to mention it like this. So make use of That is center line when 2 to 3. 2 to 3 means second column to third column. Second column to third column, I want this line. Center line. Center line means C line. Okay, that is from second column and the third column. Okay. So next one is raised box like this. These are the things. If you want make use of this, no need. These are the things. Make use of this. Sometimes this A is going to be attached with this one. Some are top of the things and then they. So otherwise the thing A with this one, this line is going to be coincident with this A and B. So sometimes that's why we are using this raised box means 1.5 means some gap between the lines and then the words. That gap maintaining here. And A and B. And then similar to if you are not mentioning column, multi-columns means this is going to be as usual as per our CCC center. If you want this one means that is this one is important. Suppose as per that. Okay, suppose one more column if I want means one more C should be here 2 to 4 like that. That's all. 2 to 4 means here is C and Q here, and next one is A and B. This one, and then here is next column. Center line over, and this one is A and B. Before that I don't want anything. So that's gap. This 100, this Q 100 will come here. Okay, this 100 is here. Okay, this one is Q is here. 100 is here, and then 100. That's all. So this is the matrix of this. 100 is here, and the A is here, B is here. Right? This one is X line, this line, and then 2010 that will come here in the formats of CCC. Is one of the multi-columns within the same cell or multi-rows, multi-columns make use of it like this. Adjustments in the tabular columns. So this is how to use our diagrams, pictures, how to include those things. Begin figure, end figure, within that we are going to include these things. So that is file name is here. File name, mentioned it, I am using this VTSD our logo. Okay, and then this is the thing. What is height? Okay, length. This is one example. So that is include graphics scale. That is a percentage wise, 25%. This is a original picture, but there's a scale like this way. Okay, and then height is like this. Width is 100 points, and the height is 10 points. This one is 25% of the logo. 25%. Original picture is like this way, but 25% means that's a percentage scale. Height and width. Suppose we mention is what is the length of the diagram, what is height of the diagram, point wise. Suppose we mention in the centimeters also, cm, inches, in also point. These are pixel wise points. So those are the things. Caption means mentioning the caption of the picture. Okay, these are output for this. No need, some of the lines are optional. If you want to use it, leave it. That's all. Okay, include is enough. So begin picture. This is enough. Okay, this is also not necessary. Include